x plus 1, or 1 plus x. The derivative of that is just 1, right? Derivative with respect to x is 1. And that means du is equal to 1 dx. Or just dx. So I'm going to rewrite the problem then. I'm going to try and rewrite the problem. I have 1 over the square root of x. But wait a minute, what's x? What's x?
Equal to u.
Well, you can take this equation and you can solve for x, right? Just move the 1 to the other side. Subtract 1 on both sides. And wouldn't you get u minus 1 as x?
Yeah.
Right? I could do that. So when I rewrite this problem, I have a 1 here. There's 1. Square root of x, but x is actually u minus 1, right? And then I have times, now this right here was what? 1 plus x was what? U. And then dx was du. Did that get any better?
Well, you can split it, right?
How do you mean split?
I mean, can you do 1 over u minus 1, square root u minus 1 times 1 over u?
Yes?
And then you get natural.
No. Because you created a product. You can't undo a product with just antiderivative of each, right?
Right.
Only if it was like plus or minus you could.
Yeah.
But if you split it into 2, it's going to be multiplication between the 2, so you can't.
Right.
Right?
Could you do this without substitution if you distributed the square root of x throughout the denominator? And then
You could try. I mean, you could try and distribute it as square root of x through here. You could. Okay, we're out of time. All right? We're out of time, so we're going to have to wrap this up. I could give this as a problem for you to take home. I'm just going to show you it real quick. I'm not going to show you. Just going to rewrite. Here's the original problem. Okay? Watch. Ooh, that's tricky. Look, you see this x right here? You could rewrite that x as the square root of x squared, couldn't you? Not something that would be natural. In fact, this isn't even really like substitution. This is me realizing that I could do it. Now, if I let that be u, what's the derivative of that? 1 over 2 root x, right? Do you see that somewhere?
Yeah.
Yeah. You have 1 over root x right there.
Right.
You just don't have a 2.
Off by a constant.
You're off by a constant. That's okay then. So I could wind up letting u here be root x. That derivative is off by a constant. This is going to wind up being arctan. But look, we'll come back and wrap that up. For homework, do the 4.7. In 5.5, I don't want you to get too deep in this because we just started. But in 5.5, the first 6 problems, and my Cal 1 students, y'all did this last semester, but it might be worth you going back and redoing. So in 5.5, just problems 1 through 6 are worth looking at because in those problems in the ebook, they give you the integral and they tell you what substitution to make. Like they say, hey, use this u. Like they tell you what the u is. You don't have to find it. So it's a good exercise in these that you can kind of like not have to worry about figuring it out yourself. And then once you do it and do the mechanical part of it, you'll kind of see how everything kind of works together.
So are you saying to just do 1?
Yeah, just do 1 through 6 now.
1 through 36?
Yeah, don't go 1 through 36. I mean, unless you want to go after it. You can go after it if you want, but I haven't really done enough examples to truly give you the real feel of this yet. All right, everyone. See. Was it? Well, yeah. Try and trust me, you'll appreciate having that extra time later to have more time in other sections.
I have a conceptual question.
Yes, let me turn off my video.
Yeah.